Okay, today we are going to talk about integer exponents, which is not a new concept. There's just going to be a couple of new rules that we're going to have to talk about. A couple of definitions first off that we need to talk about. This right here, 2 to the third power, something you've seen before. The 2, the big number in front, is called the base, or sometimes you might also hear it called the coefficient. It's the number in front of the exponent is our coefficient. And then the exponent, you're going to start hearing it referred to as the power. So you will hear this said as 2 to the third power. That just means that I have a base of 2 taken to a power of 3. Couple of new rules to talk about. The first one is any non-zero base raised to the 0 power equals 1. Doesn't matter what it is, as long as it is something other than 0 raised to the power of 0, it's going to equal 1. We will talk about the why this happens and why this is true when we start talking about division of exponents in a few days, but for now just understand this rule. So here are a couple examples. 2 to the 0 power. 2 to the power of 0, because it's to the power of 0, it equals 1. 1/3 to the power of 0, again, anything to the power of 0 equals 1, and it doesn't have to be a number. I could take a variable, w to the power of 0 equals 1. No matter what it is, if it's to the power of 0, it equals 1. The other rule is any non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite exponent. In other words, if I have this as my problem, 5 to the negative 3 power, that is the same thing as saying 1 over 5 to the positive 3 power. I took this 5 to the negative 3, moved it to the denominator, made the exponent positive. That's going to be the important thing. 16 to the negative 4 power is the same thing as 1 over 16 to the 4th power. So it just moves to the denominator. When it moves into the denominator, the exponent becomes positive. Again, the why for this we'll talk about when we get to division of exponents, but for now, know that that rule stands true. So let's do some simplifying of some expressions. 5 to the 4th, y'all know in expanded form is just 5 times 5 times 5 times 5. Well, this isn't simplified, that's just expanded. To simplify, I got to multiply it all out. 5 times 5 is 25, 25 times 5 is 125, and 125 times 5 is 625. There is the simplified expression. The next one should be real easy because we just talked about this rule. 7 to the power of 0 equals 1. Plain and simple. Now the next two have negative exponents, and we sort of talked about these just a minute ago. 5 to the negative 4 power is the same thing as 1 over 5 to the positive 4 power, but this isn't simplified because I can do 5 to the 4th power and get a numerical value for it. So this is the same thing as 1 over 625. This is the simplified version. You have to make sure if you have a number to a power, you've got to go ahead and simplify it out and tell me what that equals. Otherwise, you're not simplified. The next one, 7 to the negative 2, is the same thing as 1 over 7 to the positive 2, which is the same thing as 1 over 49. That's how we simplify. So let's simplify a few more. This one right here, this negative 6 squared. We've sort of talked about this before when you guys were plugging in and squaring numbers on your calculator. This is what you would enter, and you would end up with a negative number, and it didn't make any sense, and so then we're getting wrong answers. And so we talked about this and this mean two different things. This right here means I want to do negative 6 squared. So I want to do 6 times 6 and then take the opposite of that. Well, that becomes 6 times 6 is 36. The opposite of that is positive 36. If I put the negative in parentheses, then I am saying I want to do negative 6 times negative 6, which becomes a positive because I'm multiplying two negatives together. These don't mean the same thing. Make sure you keep up with that. It will be important later. But for now, this one equals negative 36. Okay, next example, I have 9 times 3 to the negative 4. This 9 right here has an exponent that we cannot see. It's a little invisible 1. If you don't see an exponent, you understand it's a 1. And since this has a positive exponent, when I rewrite this, the 9 gets to stay in the numerator because it had a positive exponent to begin with. The 3, however, has to go to the denominator, so I can make this 3 to the positive power of 4. And then I have to simplify this. 3 to the 4th is 3 times 3 times 3 times 3, which equals 81. This will also simplify to 1/9. So there is your simplified expression. The next one should be easy. Negative 20 to the power of 0 equals, that's right, it equals 1. Done. That should be the easiest one for you to do. Look for powers of 0. They make your life easy and fun. Yay, I'm finished. Okay, 1/3 to the power of 4 in expanded form means 1/3 times 1/3 times 1/3 times 1/3, which is the same thing as saying 1 to the 4th over 3 to the 4th. Well, 1 to the 4th power is just 1. Doesn't matter how many powers I put 1 to, it's still going to be 1. 3 to the 4th power, we did up here, it equaled 81. So 1/3 to the 4th power is 1 over 81. You can expand it this way, or you can understand that it's 1 to the 4th and 3 to the 4th. They mean the same thing. However you want to write it is fine by me. So let's do 2 more, simplify. These are a little more complicated because they're just bigger. There's just more happening. So look at this first one. I have negative exponents up here in the denominator, and you know to make them positive, I have to move them to the denominator. I think I just said that wrong. They're in the numerator. I'm going to move them to the denominator. When I rewrite this in simplified form, I want everything to be in alphabetical order. So let's go ahead and start rewriting. This 2 squared, positive exponent, gets to stay in the numerator. Everything that was negative has to move to the denominator. 2 to the 4th stays put. X to the negative 3 has to move down here. It becomes x to the positive 3. Y to the negative 2 moves down here, becomes y to the positive 2, and the z to the 4th was already here. Let's go ahead and simplify our numerical bases. 2 squared is 4. 2 to the 4th is 16. Then I have x to the 3rd, y squared, z to the 4th. 4 over 16 will simplify to 1 over 4. Then I have the x to the 3rd, y squared, z to the 4th. There is your simplified version of that expression. Let's simplify one more. This one is a little bit different. You'll notice I've got negative exponents, but this time they're in the denominator. The only thing that changes is that when my negative exponents are in the denominator, I move them to the numerator if I want them to become positive. Just like before, I want everything to stay in alphabetical order, so the a to the 4th was positive, it gets to stay. Then the b to the negative 1 comes up here and becomes a b to the positive 1. Then my c squared. And then my d to the negative 3 becomes d to the positive 3. And then e to the 0 is 1. So I'm going to do times 1. Well, multiplying by 1 doesn't change anything. So I'm going to rewrite this as a to the 4th, b, because this b to the 1st and b are the same thing, c squared, d to the 3rd. There is your simplified version. Now, if you write it like this, it's not wrong, it's not unsimplified, it's not incorrect. This is the same thing. I don't care how you write it. This is just how you're going to see it should you have a multiple choice test somewhere. So this is what you'll see, but they mean the same thing. So I like to practice evaluating and then simplifying some expressions. So I have some expressions and I want to evaluate, which means I'm going to tell you something about the variable. I want you to plug it in and then simplify. So x to the negative 1, and I want x to be 2. So this becomes 2 to the negative 1. I just substituted 2 for x. Well, this has to be rewritten as 1 over 2 to the 1st, which is the same thing as 1/2 because 2 to the 1st and 2 mean the same thing. These are equal. So I have simplified, I've evaluated and simplified 1/2. The next one, negative 4 times x to the negative 3. Well, let's do this. I have negative 4 times. Now, x is positive 4, so I have 4 to the negative 3. This is like this example way back here that we did, the 9 to the 1st times 3 to the negative 4. This right here has a positive exponent of a 1. I just don't happen to see it. So the negative 4 gets to stay in the numerator. A negative coefficient is not the same thing as a negative exponent. Negative coefficients can be wherever on earth we want them to be. It's just exponents have to be positive. So the 4 to the negative 3 comes down here into the denominator, so I have 4 to the positive 3. Now let's go ahead and simplify. 4 to the 3rd, 4 times 4 is 16, and 16 times 4 is 64. But this will also reduce to negative 1 over 16. I can divide them both by 4. There's my simplified expression. The next one, 3 over k to the negative 2, and I want k to be 5. So I have 3 over 5 to the negative 2. Well, this has a negative exponent, so I have to move it up here into the denominator, or into the numerator, so I have a positive. So I end up with 3 times 5 to the positive 2. Exponents, then multiplication, since that's order of operations. So I have 3 times 25, which equals 75. There's your simplified expression. So one last one, and these parentheses here are going to be really important. Don't lose them. Don't lose track of them. We're going to plug in what we know. So I have 5 times z, which happens to be negative 3, to the negative x power, so that becomes negative 2. Well, 5 times 3 is negative 15 to the negative 2 power. Since this is in parentheses, that means negative 15 times negative 15. But first I've got to do this negative exponent, so I have to rewrite this as 1 over negative 15 squared. And like I said, this means negative 15 times negative 15, which happens to be positive 225. So there's your simplified expression. You had to make sure that you kept up with your parentheses and your negatives. 2 important things. First of all, anything to the power of 0 equals 1. And then negative exponents have to move. If they're in the numerator, they must move to the denominator to become positive. If they're in the denominator, they have to move to the numerator to become positive. Coefficients can be negative all day long. It's just exponents that cannot be negative, so don't get those confused.